Industrial maintenance or mechatronics, whatever you want to say. Mechatronics sounds better. Maintenance makes it sound like glorified janitors.
We're gonna try to kill 2 birds with 1 stone today.
Why for birds? Birds' lives matter. Birds aren't the outside.
You guys will have a motor troubleshooting lab to do.
That's all.
Thanks, bro. You can do that.
Why am I?
That is a nice forehead. Nice forehead.
And we're just going to the meeting.
Yeah, we'll use that same ID. I'd put it on Blackboard. It should be in your email too.
What do
What do I got sign? Well, they're all out. So
All right.
don't worry about it.
Why?
Are you guys still on the other name thing, 151? Halloween.
Machine screws.
So we're going to talk about not just troubleshooting them, but making them up as per Cody's request. I need my strippers though.
Hey, strippers.
You go for a full. You know, it's different.
Light up
Which one was it? I tried to get balance on my way in.
Yeah, sorry.
I did not pay near enough attention to where you were walking.
No, I saw you coming. I didn't think you were actually going to come that close. Bill's character. He honked at me. I'm like, I'm just going to ignore him.
Yeah, and then he looked up and I'm like literally 6 inches more smoke at that. Like, whoa.
Well, good thing is.
Finally, thank
I'm going to stop letting you guys borrow my shit. Never find my shit.
you. Oh, sorry. Happy wife and wife. Like 5,000.
All right, so when you're making up a motor, take kind of some extra precautions to really safe it up good. Why do you think that is?
Really safe.
Safe it up.
You just had the apprentice up there.
Why do you think we do all this stuff?
good old deputy.
It's protected, but why do you think motor leads need such extra protection? Yeah, but I mean, why go to all this trouble? I mean, you don't want your lighting circuit to short.
Because they're taking a lot more initial energy.
A lot more initial energy.
It's the rules.
It's the rules. So you guys have given me about 10 really shitty answers.
Oh, the code is shitty.
What?
The code is shitty.
I don't know that it says in the code book that I went to do all this shit.
Don't know.
All right, number one, extreme conditions. But you don't know that. I mean, maybe you're in a hot environment. Somebody said 480 volts, but voltage doesn't really matter that much. You could have 480 volt lighting circuit. Current. Motors draw a lot of current, don't they? A lot of current is equal to a lot of heat. So that combined with we're putting this all of these little joints in this little, what's this called? Pecker bed. We're going to stuff all these joints in there, and they're going to be drawing a bunch of current. So I undid one of them, and you guys also have a homework assignment that you've already done in 150 for me, that you should see a 9-lead 3-phase motors. I would hope that we don't need to review that. You probably just saw it on the final for that 150 class, right? All right. So you should know how to make this up. This, I'm hoping, is made up on low voltage operation. If it is, I should see 4, 5, and 6 tied together. I got a 2, 4, 8, and 5. What? What the hell?
Are all those numbers from the manufacturer?
Yeah, they're numbered coming out of here. I don't know if you can see that or not, but you guys will all do this. So I'm only going to do one example, but you guys can, on those big trainers out there, I'll do that today. I'll open them up and get them all taken apart so you guys can hook them up. And I won't give you a ladder diagram or anything. You just wire it up so you can run it through the motor starter, so you can test your joints. But this is what I want you to do. So I'm not really sure what they got going on here. T, this is just T, 3 and 9. Okay. 3 and 9. 1 and I'm hoping this is 7. Yeah. 2 and 8. It should be 4, 5, and 6, right? Did I take apart 2 of those or just 1? 2 and 8. And these should be 4, 5, and 6. Okay. All right, so I'm going to do 2 of them. So T1, T2, and T3 are these black ones coming in. And they would come in through like a conduit right here. See where my finger is? See that? See what I'm doing there? Picking up what I'm throwing down? Okay.
Heard it. Just start with that.
So I'm going to strip all these out. This is a small version of what you might see in the field, like with the bigger horse motor, but they still do the same things. Like I know, like I've seen big crimp-on terminals for motor feeders, right? And you have to use you can either use big mechanical crimpers or electric battery-powered crimpers, right?
You referred to the bitch battery powered.
Not me. I like them, and I'm not the bitch.
You ever used
What the battery power?
Yeah,
they're home, though.
Milwaukee style.
I wish. I wish I had some.
I know that would.
Doesn't matter.
They're not down to scale things. Now we use stay guns and yeah, we work on sensor cameras. That's how much you're working on.
We use these little doodads. You know what these are called? What? Ring terminals. Find something more than fit in this bolt. You guys used crimpers before?
Never.
Yes.
Pretty sure that, whole. How much pressure you put on there, Zach?
1.21 gigawatts. I'm just doing this because I'm assuming you all know how to use a crimper, and I'm assuming you know like which one you use, insulated versus non-insulated. I'm using non-insulated because these are not insulated. Even with an insulated one in this situation, this is going to give you a better current, that little tip right there. So, and you're going to be dogballing the shit out of these with Cambridge tape and all sorts of other tape. So,
Put the tip on the opposite side of the slot.
I don't, maybe there's a way you're supposed to, but it doesn't matter to me.
The opposite side of that slot. Put the tip into there, it's just like
Break it apart.
Just the tip to it.
I don't. Yes. So what am I doing? 2 and 8 and T2. I'm guessing this is T2, right? And then you just bolt them together. Well, depending on where you're working, they might even have like torque specifications on these, but I'm not worried about that right now. I'm just gonna bolt some bitch together. And then I'm gonna show you how to dog ball the fuck out of it. You ever heard of that terminology before? This is a dog ball. I'm not doing anything fancy. I don't have wrenches. I don't have torque wrenches. So then this should be 4, 5, and 6, right? Can y'all see what I'm doing okay on the camera? Making dog balls. All right. Now this next part is pretty standard operating procedure. This is called cambric tape. Cambric tape. Varnished cambric tape. If you read the description on back here, heavy duty electrical insulation that provides mechanical protection and puncture resistance. Insulates joints requiring rapid and clean reentry. Motor lead and service drop connections. Pretty typical. Heavy split bolts and raceways. The point is that these are going to experience a lot of heat and a lot of pressure, and they're going to be crammed into this little thing. So with a lot of motor draw, you can get leakage current. And I'm going to try to demonstrate that with the Megger, because you're going to need to know how to use the Megger anyway for your lab. But you can get this stuff with or without tape. You can get it for adhesive. If you get it without adhesive, have fun with that. It's not very easy to work with. And then I proceed to dog ball the fuck out of it, right? You know, since having you guys in class, my language has really gone downhill. I don't know what it is.
Yeah, we got first the other day.
Did you?
Yeah, we got
What did he say? So I can use it against him.
What was he telling me? It was when he was calling his ass.
His ass? Oh yeah. On the Christmas ornament.
That meeting thing, wasn't it? You had to go to homeowners association to kill some of these trees or something.
What? So we were at a family reunion, and my dad's an engineer.
Wait, exactly.
No.
You're on the Maury show and you said not to die.
So we were at a family reunion. My dad's an engineer, and he's a big, basically nerd. So he's always into like the latest technology and stuff. Back then, iPads were like the newest, biggest thing. And he left his iPad sitting there. And so Steve and I snatched that thing up and took pictures of each other's ass and set it like as the background, or I guess whatever you want to call it, just to mess with him. So then my dad, in turn, took those pictures and made a Christmas ornament out of it. And pretty sure Steve still uses that ornament on his tree.
Did he text you yesterday about moving my mouth?
Who was in your mouth?
We told Steve about the who's in my mouth thing.
Yeah.
He said he was gonna text me about
So who is in your mouth, or who was in your mouth yesterday?
it. No,
Are you feeling better, by the way? Did you get tested?
I did not get that.
So you can come in here and give us all a bunch of whatever you had?
Have you had the test yet?
Yes, I have.
Not the greatest feeling in the world. Yeah, I didn't know they didn't make it spit and stuff. Like, they didn't give me the fucking option. Like, here, let me shut this.
You got it.
Like 2 months ago, yeah.
Okay, so can you guys tell by the connections whether this is a delta or a Y? How do you know? Low voltage is 4, 5, 6 parallel operation. Okay, whether it's delta or Y, in this case, this is our motor. So inside the motor casing, this is how the windings are arranged. This is not what they look like if you would open it up, but this is how the connections are made. So parallel, that means there. Right? Am I thinking that right? Either way, what you end up with is this. Right? Okay, well, some of those connections are made interior inside, but this section right here, do you think the amount of resistance from this point to this point would be the same or different as from this point to this point? Very similar. So all those motor windings are about the same length. If they weren't, you wouldn't be getting consistent rotation, consistent force going around 360 degrees, right? So that's a key thing to keep in mind when you're troubleshooting motors. You can take resistance readings and compare them between each set. So in this configuration, so right now, since I have that hooked up and I have those joints made, this is what it looks like. And what I have coming off of here is T1, T2, and T3. So I can also take resistance measurements from T1 to T2 would be all the way through here. That should comparatively be the same as from T1 to T3 or T2 to T3, right? So let's say this is 20 ohms. Let's say this is 20.6 ohms, and this is 19.8 ohms. Is that a good or a bad motor? It's fine. What if this one is 6.3 ohms? Bad. So what happens in that case? Short. Partially shorted, right? So that means somehow, some way, remember those windings are stuck really close together inside that motor. Somehow, some way, let's say maybe this point is touching this point, right? You have a partially shorted set of windings there. So the resistance from here across that junk means less copper, less resistance.
That good or rule of thumb for like how much variation you can have between those before like it would be considered a problem?
It's a good question. I would say no. I would say they're either going to be pretty close or they're going to be way far off. And I honestly haven't seen in the field something partially shorted, but I'm sure it happens. So that's one problem that you could have. And remember, you're just checking this with the meter, right? You're just checking ohms with the meter. We haven't touched the meter yet. What if this says 20.6 ohms there, and your meter says OL and OL. Yeah, so one of these, or probably T1, it's gonna have to be T1, it's broken. If you had this open, you'd still get a reading across from T1 to T3 and T1 to T2, right? So if you're getting OL on both of them, that means T1 is open somewhere. Probably before you even get it, probably in the joints, right? That joint third part or something. You would have to have both of these open to get one of the motor windings open, right? Parallel. In series, you could have one of those open and you would get no resistance value, right? That makes sense. You can draw it up. I'll draw it up. Oh, it is. Look at that. So let's say this is a high voltage operation. And we've made these connections. Would be series them. And let's say this is T1, T2, T3. You could have 20 ohms and then zero or OL, or not zero, it'd be infinite ohms. It says OL. I think OL stands for outside line or something like that. Basically, no continuity, infinite ohms. So in this case, it could be the T1 connection up here, or it could be this one is open, or it could be this one. Right? But you're not getting any continuity on there or there, but you have it across there. Right? So when you're checking resistance on motor leads, okay, you won't have to do this, but let's say these tests are done with those connections made, right? They're all shit. What if I get this? Can I troubleshoot it even further and say which winding is it? Is it this one or is it this one? One of those windings is open. Can I troubleshoot it even further and see which one? I can't think of a scenario where you have to do this. At this point, you can say, okay, is it cost effective to have the motor rewound, or is it cheaper just to get a new motor? Probably depends on the size of the motor. But yes, you could figure out which winding it is because each of those leads is numbered, right? So you ask, like, are they all numbered like that from the manufacturer? Yeah, they are. So in this case, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So I could test from this connection is made internally. So I can test from 7 to 8 and 7 to 9 and see if I get readings. I can test from 1 to 4 and see if I get a reading. If I get nothing from 1 to 4, then I know that's the one that's open. Right? Okay. Well, for your lab,
Is it necessary, like, say you're testing a motor and resistance is the same? Check use the ground too, just to like verify. I'm sure.
Necessary? Is it necessary for me to drink my own urine?
No.
No, but I do it anyway.
I see you guys do it all the time. I don't know.
Drinking their own urine?
No. Just checking the ground even after they checked
Yes.
everything. Checked okay.
With a meter?
Yeah.
Yeah. Problem is, sometimes your meter ain't gonna pick up leakage to ground. That's what the megger is for. So that's a good transition into the next talk. Real quick though, I want to test these just to show you what readings you might get in real life. So I've got this hooked up in parallel operation, so should get pretty low resistance values, but they should be pretty similar. 1 to 2, 2 to 3, and 1 to 3. So I'm just going to check them real quick. By the way, this is the first part of your lab, is doing what I'm about to do. T1 to T1 to T2. 12.3 ohms. T2 to T3. 12.3 ohms. T1 to T3. 12.3 ohms. So far, this motor is good. T3 to ground, nothing. T2 to ground, nothing. T1 to ground, nothing. That's good. That's what we want to see. The next part is a megger. Let me test this motor first. I'm just curious which one I grabbed, what the readings are. T1 to T2. Four point 42.1. T1 to T3. 42.1. What was the first one I did? 1 to 2, 1 to 3, so I need to do 2 to 3. 46.3, so we're good. Now these are the motors that you're going to use for the lab. These Teal Reliance Duty Master AC motors. Some of them have faults and some of them are good. You're going to have to figure out which is which. There is no ground for these. I really should probably provide you with a ground, but for the purpose of these, you're not with your meter going to test the ground. You're going to use the megger, but a ground on this would be anywhere on the casing, right? Because you're assuming that whoever the electrician that hooked this up is a good electrician and grounded the casing, right? So if a winding does burn up and ends up touching the casing, it'll trip a breaker or trip the overloads. Okay. Next. So why do you think you could, in some cases, let's say this motor, we just tested everything to ground and they all said, oh well, right? So we think we're good. Well, we put it into service and it keeps tripping an overload, it keeps overheating. Why would that be? We already talked about these things draw a lot of current, right? Sketchy. Yep. Yep. And I have seen this in the field where you can test something with a meter. You have no continuity to ground. You have good voltage coming in to whatever your a motor, lighting circuit, whatever. and you're still having problems with fuses blowing or whatever. That's because when you put a load on a system, especially a motor, a high load, if there's any a pinhole in the insulation, you can get leakage current, and that's what meggers are for. Meggers put up to, this one goes up to 1,000 volts, and you might not think, no, I think puts out 1,000 volts. Well, try it. Don't try it, but you will feel it if you put, you know, put one of these on each of your fingers or your nipples. Yeah, you can do that, but
Put them on balance.
putting that much voltage on those windings, if there is some kind of leakage current, it'll pick it up. So I want to use this on this motor first. I'm just curious what it says.
How much one of those runs back?
$9. I have no idea. I've never paid for one.
410. Big old son of a bitch right there.
She said.
Big. Not this. Yeah.
You can see that. Yeah, and that really depends on what you're working with. It's best to start with the lowest setting. In this case, it's 250 volt. And I'm just telling you, for your labs, you won't need to go higher than 250 volt. Okay. Running it at higher voltage, if you continually run a Megger test at a higher voltage, you'll eventually start to break down the insulation of that system. Central spam. So it's best to start off with the low scale. If you're doing the low scale and you're getting readings that are sort of, I'm not sure, then you might want to bump it up and really put some higher voltage on it to see for sure that it's bad. But this is, so on your lab, you're just going to find some kind of good ground on the casing somewhere. Don't put it on the shaft. That's not going to be a good connection. You can't see this on the camera. Okay, first I should show you is if I do this and then hit that button to test it, what should I see? Or what result would that be? A direct short. So basically 0 ohms, a direct short. And I'm doing this for you so you can see what it shows you, because you will have this result on your labs. So to test, you put it on whatever scale you need, and then you hold down the yellow button. And then this, what you're seeing there, 4 dashes, means basically 0 mega ohms or direct short. That's bad. Okay? So if you see those, that's bad. I'm going to test this one and see what we get. So this is T1. You want to make sure you have everything isolated. You don't have, some of these motors are sitting up on a block of wood, that's good. Some of them are sitting on the table, that's fine, as long as your leads aren't touching the table, then you'll get bad readings. So I'm testing T1 to ground. Hold the button down on the 250 volt scale. Oh wow, what does that mean? That's good. That means lots and lots and lots of mega ohms. T2. Oh well. T3. Oh well. So this motor, if I remember right, from the ohmic readings and from the Megger, this motor's fine. This motor's fine because, well, I guess I could test it.
Get some chills.
But I do want to try to simulate something. So T1 to ground. Oh well, so this is going to test out fine. I want to try to put, let's do it right here. I'm going to take T3 and I'm going to smush it underneath this screw and hopefully compromise the integrity of its insulation. So basically, if you ever see that question on a quiz or homework, what is the purpose of the megger? It tests the integrity of the conductor insulation. This is not tightening for shit. Anybody know what integrity means? What?
Hold up or stay true to what it's supposed to be doing.
Yeah, yeah. So I kind of smushed that down into that screw, and this ground is made up to the casing. So I'm going to try to see if I get a reading now. So back to the definition of integrity and what a megger does. Think of it like the water pipe analogy, right? So electron flow, current flow is like water in a pipe. A bigger voltage is like having a bigger pump or bigger pressure, bigger force on that water. And current is the amount of water passing through a given time, passing through one point in a given amount of time. And then resistance would be whatever's resisting that current flow. So think of bad insulation like a tiny little pinprick in the water pipe. Under normal operation, maybe you get a little dribble of water every once in a while, but you put a lot of current flow and a lot of voltage on there, and you're going to get more and more water leaking out of that pipe. That's what a megger shows.
Like when we had 350 gallons of fucking quenchant leak out of a quenchant tank. Because there was a little tiny hole in it that no one checked for like 4 weeks, and it just, well, not that long, but like a week and a half, and it just kept leaking and leaking.
Quench it?
Yeah,
What's
we had
quench it?
350 gallons of quenchant leak out of our quench tank.
Don't put the different parts in after it gets out of the oven.
One for makes and loses 400 gallons of hydraulic oil every day.
Jesus
What?
Christ. Who cleans that?
400 gallons?
400 gallons.
Who cleans that mess?
Okay, so I'm testing to, you all saw what I did, right? I smushed that wire down a little bit on that screw. And so this is to simulate, maybe, think of this as the motor winding inside there. Maybe that insulation is starting to break down just a little bit and it's touching the casing. So I just want to see if I can simulate. Nope, nothing yet.
You trying to blow something up here today?
No, it won't blow anything up. Shit. Try to
You like
wash
getting
it.
hand jobs? No? You like getting hand jobs?
I need a washer.
Fucking hypocrites out of it too. Zach, you ever seen that Harold and Kumar escape from Guantanamo Bay?
Mm-mm.
Oh, what? Really? Have you seen the first Harold and Kumar?
The White Castle one?
Mm-hmm.
Long time ago.
Highly recommend watching the second one. It's better. The order of cockney sandwich.
Something wrong with you.
Yeah, there's that's an understatement. Here.
I don't think I ever told Zach's story of the poop night. did I?
What? Ballard, we don't want to hear about the damn poop night again.
Poop night?
Poop night. These are made up stories. We make these up.
Obsessed with this thing.
I heard it and I thought it was hilarious.
Thing they're going to talk about.
I thought Zach would be entertained by it.
Ballard, you have a poop fetish or something?
No.
You should, your wife should.
Speaking of poop, where'd Jay just go?
I forgot his poop night.
Yeah, there's a dude I work with, just use a screwdriver. Stick his hand in there.
What?
And eat after that.
In the shitter?
Yeah, no, stick his little hand in there.
I'm gonna tighten down a little bit more and then I might bump it up to the 500 volt scale.
always ask him on the calls.
The kid, Tony, does that with his fingers. He's like,
I'm not kidding.
Try 1,000. Damn.
Is that a reportable injury on your finger right there, Zach?
What?
Is that a reportable injury on your finger right there?
No.
So you guys have a guy that reports everything at that cat, like get the fucking paper cut. There's always that one guy that reports like everything.
Oh, am I not getting any? Oh.
There's a dude in Morton, he would literally get the fucking paper cut and he'd like go and report it.
Like a bitch. Once I was replacing roller chains for conveyors. Picked up the segment of the chain. Got a splint. Metal, of course, metal splinters always hurt worse. So I'm digging at it, I just can't get it out. So I go to medical. Can't simulate it. She's like, yeah, I kind of see something, but it doesn't look like much. I'm like, this hurts worse than any metal splinter. You just try to digging at it, getting it out. For like 30 minutes, but she finally got a hold of it and pulled out something metal like that.
you're like, oh.
When I get back, it's like, who did you put in medical for splintering? I'm like,
Sometimes splinters
yeah,
fucking
Big
kill.
fucking
the
metal
thing
ones.
was that long.
I had a piece of wood that was about that long that got shoved underneath my fucking fingernail one time, dude, and spent like a week trying to get it out, and it just kept hurting, and my fingers started fucking swelling up. I had to take a razor blade from my fucking fucking knife or my sharpener blade or whatever. I literally just sliced down my fucking fingernail and then cut my whole fingernail off to get it out. I finally pulled out. It was like nothing left of it. It was just like disintegrated at that point, but it was fucking hell.
We had a fellow, one of our electricians, was feeling the rail on barehanded, of course. Picked up a splinter that went all the way through his fucking finger.
I think it's more of a splinter, more than just a splinter at that point. Boy got stabbed.
Yeah, and he stabbed himself.
I was really hoping I could simulate this so I could see what it would look like.
I believe in you, Zach.
Different body, yeah.
There we go. So now I can see a little bit of copper in there. I'll give it one more shot before we just take off and go to labs. Oh, you asked about rule of thumb earlier too. You might see this, or you could probably use it on the lab, but the rule of thumb for these readings is going to be 2 megohms. So, and you use that at work too, but if you see something under 2 megohms, that's a lot of ohms. That's bad juju. At that point, it will probably continue to get worse and worse and worse until it just fails. Come on. No. Shit. All right. Anyway, you will see readings on some of these. Okay, so then what you have to figure out is it under or over 2 megohms. So if you do want to do these, there are worksheets over there. You're just filling it out. There's 3 columns you're going to test. T1 to T2, T2 to T3 with your meter, just checking ohms. And then with this guy, you're going to check each one to ground. Okay? Understand?
What if you're using a megger, not checking like motor windings?
Yeah, I've checked underground with it.
Where you put your leads at in that case?
ground. So if it's underground and it's in a conduit with water, or even if it's direct buried, there's gonna be some kind of moisture in there. So wherever you're checking it, in a cabinet or a panel or whatever, you're gonna have a good ground, something going to a ground rod, so a grounding electrode conductor. That's where you would put one lead. Okay, and then this would just go on whatever conductor you're trying to see.
You wanna make sure that's disconnected from the circuit.
Depends on how you want to check it. If you think the fault is it's going to ground, you could use this to check. I could use this to check against each winding too, right? So in that case, I would want to isolate this winding with all these other ones, right? But if I wanted to check, let's say I could put one lead on 2 and one lead on 8 to make sure this is not touching or rubbing against these 3 somehow, some way. You can check them against each other too. They're not just for ground faults. But a lot of times something that bad, if it's shorted together, will show up with your meter. But anything else? I'm gonna keep looking at your code question. I'm not sure what it's asking you to find there, but if there's nothing else, labs. Lab time.
Sir Reasington? Pizza Daddy, I'm guessing that's shit. Huh? You Pizza Daddy?
Yeah, not to my knowledge, but